Hey everyone, welcome back to Ask Becca About Space. Once again, just sending you all the best from Norway and hoping that you are continuing to be well during these times and providing you with standard content with a terrible Midwest accent as per usual. So I don't actually have any questions in the queue from any kids right now. So first of all, if you are someone who's curious about anything, please feel free to send them to me. But second of all, today I just kind of thought that I would talk to you and check in once this week about some kind of frequently asked questions that I get from folks, just kind of over and over. So yeah, let's just do that. Also, I switched my glasses, but it's still me. Hello. Okay. One of the most basic questions that I get from people is just simply, why do you do what you do? Like, what is the actual point of what you do? And totally fair question. Like, I get it. We kind of have seen throughout history, throughout the past several decades, pre-space race and post-space race, dramatic changes in public opinion on space research, whether or not we should be funneling funding and especially tax dollars into space research when we don't have very fundamental things available to the entire American public. Agree, hard agree, 100%. This was particularly relevant when we were trying to, of course, like again, space race, trying to get to the moon. And after the public kept seeing spacecraft just kind of like blow up and stuff, they were like, cool, why are we still paying for this? I get it. That's a fair question. But I will point out that if stuff doesn't blow up, then we don't always know what's wrong. We don't always know how to fix it. And trial and error is a very, very big part of science. It's just that for me, as someone who's more or less dealing with computer simulations and observations from spacecraft that in fact did not blow up and are successfully in space, my errors don't cost, like billions of dollars. So for me, it's a little bit more low risk than for those who are designing spacecraft in the first place. But again, what's the point of studying the sun? Isn't it just the sun? Well, yeah, it is just the sun. But I think a lot of people don't know how much we don't know about the star that sustains us and gives us life and light. And for me, not being able to fully kind of understand this life-sustaining resource for us is a big deal. But more than that, let's go back to the 1800s. In 1859, there was an event that was later called the Carrington Event. And this was basically a situation where the sun had a magnetically energetic explosion that was so incredibly huge that it sent plasma through space to the Earth. And when it got to the Earth, the resulting geomagnetic storm was so enormous that people could see northern lights as far south as Colombia and southern lights as far north as Queensland, Australia, which is insanity. Those are basically equatorial latitudes. And for us in normal times, northern lights are generally confined to, well, they're strongest in like the 60s and 70s latitudes, and you can see them, if they're good, down to kind of low 40s, maybe high 30s, but never that close to the equator. That's insanity. Now, luckily for humankind, in 1859, we didn't really have the energy grid that we have now, right? The energy grid in 1859 was basically the telegraph network. And when this storm hit, when these sun particles hit the Earth, what happened to the telegraph network was total chaos. Basically, you could send and receive telegraphs without being connected to a power source. because there was so much energy available just kind of in the air that telegraphs were sending left, right, and center without needing an external power source. Now, extrapolate that to 2020. I don't want to speak any more chaos into the current year that we're living in. However, if some storm of that magnitude were to happen today, it's likely that it would completely wipe out the energy grid that we have now, not to mention pretty much every single satellite we have. Okay. And that is a big deal. And parallel to the disease and pandemic researchers who knew that something like what we're experiencing now was inevitably going to happen, solar physicists know that something like the Carrington event is inevitably going to happen again. We just don't know when, and it's really difficult to predict that. In fact, we've seen huge solar flare and huge coronal mass ejection events on the sun like that, but luckily they just weren't facing the Earth. They went somewhere else in space and messed them up, just not us. But we've seen them again, and we will see them again. And statistically, one of them will be facing the Earth again. And so it's incumbent upon us as researchers to spend our time understanding what generates those kinds of explosions and how, if in any ways, we may be able to prepare for it or have some sort of plan B when the energy grid completely wipes out. Now, of course, there's only so much we can do in those cases. But understanding these events starts at the very basics of how stars work. Okay, so while I am not a person currently who's dealing with space weather forecasting, there are heaps of people that are looking at space weather forecasting and how we can tell how big these storms are going to be and things like that. I'm starting a little bit before those explosions happen, and I'm trying to understand the dynamics of the magnetic energy that has to happen to drive those explosions, or just to drive energy moving into the sun's atmosphere, because these are things that we don't fully understand yet. And so people like me are working on problems like that. And that is the point, essentially, of what it is that I do. Job security wise, it's kind of nice that there's a little bit of drama attached to what I do. Because if nothing else, the US military will fund research like this because they're very concerned about their communication satellites going down, and they need to know if there is a chance that their communication satellites could go down. Of course, we all need to know if there's a chance that the energy grid could go down, because we need a plan B. We need to know what to do in an emergency like that, right? So at least I feel like there's a little bit of job security there, so that's nice. However, you should know that I am not funded by your tax dollars. I'm not funded by my US tax dollars either. I am actually funded by an entity called the European Research Council, and that money is specifically allocated to fund scientific research. So this is money that is already set aside for scientific researchers. Okay, so that is a little bit on the kind of the why, like the what's the point of studying the sun. It's the sun, it's there. What else do we need to know? Well, it's important for us to understand how the sun works in order for us to understand what the sun can do. Okay, so again, if you have any other questions, please feel free to let me know. I'll try to think of, I guess, some other frequently asked questions that I get maybe for next week's video, but otherwise, if you guys have anything that you'd like to know in particular, just let me know. All right, please take care and please be well. All right.